Well, good morning and good afternoon, everybody. Tom Judd from IFMBE Clinical Engineering Division, and we welcome you to this fifth of the 5 town halls that we scheduled. And today, remind you that the World Health Assembly is happening this week in Geneva. Well, by way of Geneva, it's all virtual for the 194 member states. And we actually included in your read aheads a statement that IFMBE put before the WHO World Health Assembly, and you can see that it asks for more clinical engineers around the world. So we've made big contributions in this important time. And I'll also alert you that we are going to have a wrap-up town hall this Friday. Each of the 5 topics that we've covered, we've been sending out somewhat piecemeal. We've been posting a bit, some of the answers to questions, but we're going to put summaries together and try to answer as many questions in the hour town hall this same time on Friday, May 22nd this week. That said, I'm going to turn it over to our co-chairs. Dr. Basakalov has been teaching clinical engineering around the world in South Africa and now in Canada, and clinical engineer Jennifer Jackson, an outstanding US-based clinical engineer, now working for Massimo. Bassett.
Thank you, Tom. Good morning, good afternoon, good evening, everybody, and welcome to this 5th in the series. It's a great pleasure to be here today with you, and words of thanks to WHO, represented by Adriana and Tom, from the International Federation of Medical and Biological Engineering, the Clinical Engineering Division. And today, our topic will be on ventilators. It's a hot topic. And together with my colleague Jennifer, we will chair this webinar today. We have a number of speakers, and we will introduce them later as you see them on the agenda. Before we start with our first topic, I would like just to indicate to many of us that ventilators are considered as a life-supporting equipment and classified as a high-risk device, which means that it's an equipment that requires frequent and periodical maintenance, inspection, and safety testing to avoid getting into any incidents and faulty functioning device. So please take note of that and prepare yourself if you're not ready to take care of your ventilators. Without any delay, I would like to introduce our first speaker, Ale Beliza, representing the WHO today and from Mehra, UK, regulator. Over to you, Ale.
Thank you very much for this introduction. Yes, let me share the screen with the presentation. You can see it now? Yeah.
Yes.
Okay, perfect. Well, to introduce me fast, I am Alejandra Vélez, biomedical engineer working in the health emergency program together with Gabriela Jimenez and other members of the team. We have developed some, and Adriana, we have developed some guidance that I will, what I want to share you in this presentation. So some of the publications related to the case management that you have been following during the seminars are the priority list of medical devices, are the technical specifications for invasive and non-invasive ventilators, the technical specifications for oxygen delivery and monitoring devices, the inventory survey tool that can also help you to assess the healthcare facility readiness for this kind of equipment. The oxygen sources is an interim guidance I will show some details of it. And we are now developing training guidance for the 5 types of ventilators. This is a project in progress. You can find all this information in the links that are here. More or less, it looks like this when you click on them. It's important to scroll down a bit to find the information because it has been developed so much guidance that sometimes it's difficult to go through them. We also have in the website the emergency supply catalog. This is a tool for the countries to go directly to the products that can be procured or that WHO is supporting through the ministries of health to procure. Once you go through this catalog, you can find 5 different types of ventilator, as you can see in the screen. Also, some are the non-invasive ventilation like the BAP, CPAP, and the high flow nasal cannula that has been discussed in previous seminars. And you have also the ventilators, the intensive care one, and the transport or mass casualty ventilator. For all of these ventilators, we develop technical specifications, as well as for the, as I mentioned before, for the oxygen therapy and monitoring devices that needs to be taken into account as a whole package when we procure equipment. This is one of the screenshots of the guidance of oxygen delivery devices, just to let you know that it includes also some clinical advice on how to use or how to combine the devices once you select them. Also, before going deeper to the ventilation, I wanted to mention this publication because this is basically a main component before procuring or assessing the ventilators. We need to know which kind of source of oxygen we have in our health facility. So for the time being, we have compiled this publication that is based on a previous work done with WHO and UNICEF. And together with this, we have developed also the technical specifications for the PSA plants, so that are also publicly available. Then going through the specific process of the ventilators. The first thing, as you know, it was to develop the priority list of medical devices that will be used for case management. This list includes everything in the ICU and for the severe and critical patients. As you can see in the screen, there are some comments regarding how to select one or other equipment, because it doesn't mean that you need all for the same things. You need to assess your infrastructure, your clinical staff, etc., to take a decision. We also, in this list, we are also recommending, according to the level of care, what is minimum to be procured. After developing this priority list, we went through the compilation of the technical specifications. It was a process where we include international experts to discuss what were the minimum requirements specifically for COVID, including the ventilation modes that were really appropriate for this purpose. As I said, this kind of publication includes part of the guidance, like for example, we need a source of air and oxygen with certain pressure. We need to consider some air compressors or blenders with the specific characteristics. And if I go to more details, we are putting the general requirements for the equipment, including all the ingress protection and the ventilation modes, the parameters that need to be controlled and monitored by the user. And we have a section where we include an approximation of the approximate quantities of consumables and accessories that needs to be delivered in the first procurement. Considering that this process of procurement takes time and that we won't be able to, the shortage of supply that is globally happening, and we won't be able to do the refurbishment soon, we are pushing to have this from the first delivery. As I said, quantities are approximate, so of course you can play a bit of need when you are doing your own procurement. We suggest to include a disaggregated list of them and to indicate if they are brand or generic. So you can also have from the beginning, the calculation of cost that it will have the life cost of the equipment. Also, it's very important to include a comment on the language of how the product comes, the documents that are together with the equipment, but also how they are giving you the interface. So for the time being, we are including minimum the English language, but of course, this is something that is preferable to be in other language, local language, of course. And what else? We also emphasize in the use of a reliable and continuous source of energy, because we know this can damage the equipment. Finally, in terms of the quality assurance, we are including some, here I just put some of the main things that we need to take into account. One is the packaging, the labeling, the information of the manufacturer, the distributor, or the authorized service people that will be on ground. Also, we are requesting some standards. We know this also has been changed and adapted a lot during the emergency, because equipment comes from different certification bodies or regulatory bodies. So there is no linear equivalence of the standards, but once we know what it's including the standards and what parameters we want to or results we want to get from this test, we can request to the manufacturer, including the assessment of a regulatory body that gives a certification of exportation or free sale certificate previous the commercialization in the world. Then with regards to the guarantee, we are requesting the equipment to be at least with 2 years life, 2 to 5 years lifespan. So meaning that the software, the availability of accessories, consumables, and spare parts will be guaranteed for this period, so that we can be sure that the equipment will be running for at least that period of time. This that I show in the screens, it was related to the ICU ventilators. However, we have the transport and the mass casualty ventilators in our specifications, because we know the shortage of supply and all these problems. So we are including, but we are not saying that they will supply, or we need to take some considerations for long-term patients in ICU. So to more or less to summarize also other aspects that we continuously mention about the holistic assessment of technology. We know that for this kind of equipment and for many equipment, we need to take into account the installation requirements like power supply, medical gases, that includes the inlet pressure, the regulators, the connectors. I just put a screenshot of different kind of regulators and fluometers that need to be used according to the low or high inlet of oxygen and air. Also, we always need to know that in place we will have staff, clinicians, nurses, clinical engineers, and technicians to run the equipment. And procuring one of these equipment is also subject to the availability of other devices like the intubation or airway management devices. Also, if we are considering to buy breathing circuits that are reusable, we will need to talk about sterilization and other decontamination process. Finally, we wanted to mention that we are aware of all these fever of manufacturing and creating and solving the problem on innovations. So we are assessing this situation with two perspectives in WHO. One is about the emergency use authorizations that has been provided by some regulatory agencies like the FDA or UK. And we are evaluating case by case and comparing if they comply with the specs. But we know that these products maybe need to be reassessed by the regulatory bodies after a period of time. And on the other hand, we have other innovations that for the time being, the way to assess them is through the website that the information goes, the innovator needs to fill a survey tool, an assessment tool of the stage of the innovation. They submit it, and we kind of provide feedback of what is the way forward for them before these devices are commercialized. But we are not procuring these devices as WHO. Finally, just a reminder that there is this inventory tool for COVID that it also can help as a guidance for readiness for your health facilities. So please fill it. Here you will see some questions about the availability of power requirements and the inlet oxygen and air inlet pressure, etc. And that's all from my side. I think we continue with the presentations and then questions maybe at the end. Thank you.
Thank you, Alejandra. You finished exactly on time. Thank you for keeping the presentation within the time. And I would like to welcome our co-chair, Jennifer, joining us in the webinar. And before I hand over to her, I would like to remind all participants to prepare their questions and use the Q&A to share their questions with us, and we will take care of that in our last session. The second issue, I would like also to alert everybody that ventilators are used in an oxygen-enriched environment, and most of the time in many countries we use compressors for the compressed air, and that is a source of danger in case if we may ignite a fire. We had an incident a few days ago somewhere, and that is not the only incident, but we also had an incident in 1993 in the USA where a ventilator was involved in a fire. So please take note of the requirements for fire and look at the standards published by the National Fire Authority that will guide you how to protect your environment from fire. And with that, I would like to introduce our co-chair, Jennifer. Please, over to you, Jennifer.
Thank you so much, Bassett. And good morning to everyone. It's morning here on my side of the world. It is a great pleasure to share this morning with you on this wonderful presentation. Thanks to the group for inviting me to co-chair. At this time, I would like to introduce a phenomenal speaker, someone with a wonderful, experienced career in clinical engineering, with a great focus on critical care medicine and ventilation, mechanical ventilation, and respiratory therapy, and the application of technology to those areas. So without further ado, it is my pleasure to introduce Tom Larkin.
Thank you. I'll just share my screen now. Okay, bear with me. Okay, can everybody see that? Can everybody see my
We
screen?
can see it, Tom. We need you to get your voice higher.
Yeah.
Okay. Okay, sorry. Can you hear me now okay?
Still a little higher if possible.
Just bear with me for a sec. Okay. Is that better?
Yeah, please proceed.
Okay. So before we commence the ventilation presentation proper, I just have a couple of slides about the training and education initiative in Ireland, which led directly to the development of this series of mechanical ventilation educational presentations that I'm doing now for medical, nursing, and allied health care professionals, including clinical engineering technicians. This was for non-ICU staff. So let me just move on to the next slide now. So this initiative was taken in response to a call by the Irish government nationally and worldwide to Irish people abroad to be on call for Ireland. It was launched to encourage medical, nursing and other healthcare professionals to return home, come out of retirement, or redeploy from other areas within the public healthcare system in Ireland to support their critical care colleagues within the healthcare system, particularly in relation to mechanical ventilation. Worldwide, I think we got something like 70,000 responses to that call. So lots of people came home, redeployed in the hospitals, and came out of retirement. So these are the sort of organizations that we supported. So the Intensive Care Society of Ireland, I'm a member of that as well, the Irish Association of Critical Care Nurses, and of course the Biomedical and Clinical Engineering Association of Ireland, which is the talk I'm going to address today. And what I've been doing is developing over the last few weeks bespoke kind of targeted presentations for these various categories of people. So your non-ICU nurses, non-ICU doctors, clinical engineers and medical physicists here in Ireland, and then refresher training to former specialist staff, nurses, doctors and engineers, and people coming out of retirement. So that's just an overview of what, if you like, led to this series of presentations. So I don't have time today to go through the full presentation on this particular topic, which is the basic principles for medical physics and clinical engineers. So what I've done is I've made a small selection of slides relating to each section in the talk to give you a flavor of the topics covered in the full presentation. So the presentation is divided into 5 sections, sort of reference material which people will need to study further in order to help them understand more about mechanical ventilation, respiratory system modeling, negative pressure ventilation, spontaneous breathing, mechanical positive pressure ventilation goals and terminology, and then a brief discussion of ventilator modes and settings used for C19 patients, current versus original strategies. Things have changed since the outset, the strategy for ventilation. So we need to look at that as well. This is one of a series of talks. So this is the very basic. It goes on to more advanced and more advanced again. So we talk about mechanical ventilation modes, graphical analysis and ventilation strategies. So this is one of the reference material slides. So it's just to, if you like, I think it's very important that clinical engineers have a good understanding of the cardiopulmonary circulatory system and to be familiar with some of the terminology that's commonly used in relation to mechanical ventilation. So again, in the presentation, I just describe the function of the cardiopulmonary system, the four valves in the heart as a pump, and the circulation. And then we just kind of look at some of the sort of interesting points in relation to the total surface area for gas exchange, alveoli number, a little bit about the alveolar capillary membrane and so on. And the cardiac end of things, just talk about the cardiac output, stroke volume and heart rate, and how the cardiopulmonary system work together. And this is another slide, again, just to give background in relation to lung volumes and capacities, where the tidal volume is sitting on top of the FRC, if you like, and the various other capacities, total lung capacity and so on, which I think is important for clinical engineers to understand. It's a little bit on normal blood gas values, the usual ones highlighting pH, PaCO2 and PaO2. And then just sort of an overview or a vision of the thoracic cage and the diaphragm and the intercostal muscles and so on, and explain the pleura, the parietal and the visceral pleura, and the function of that anatomy. And again, just a little description on what these things are. Then we look at, for engineers in particular, respiratory system modeling. it's useful to have a multi-compartmental model of the respiratory system that they understand, so an electrical or an electronic analogy. And again, we see the ventilator as a constant pressure or flow source. This is the inspiratory valve. We have the circuit compliance, breathing system compliance in parallel with that. And then we have the various components of the breathing system, the breathing system resistance, the ET tube. The lungs are represented again by a resistance and capacitance, mimicking resistance and compliance, and then the chest wall compliance. And then I go on to explain that this can be like equivalent. You can reduce this to an equivalent circuit, which is again just a ventilator as a constant pressure or flow source, total resistance, and total compliance, which is what we tend to do when we're using lung models to test ventilators. But obviously, the physiology is much more complex than this electrical analogy, and much more complex than this equivalent circuit. So I do talk about then, but this is the stuff you'd see primarily in the medical textbooks. They discuss the tube and balloon model and the ventilator input, again, constant pressure and flow source, and the relationship between the pressures, and in particular then the equation of motion for the respiratory system, which relates all these functions together, details what the flow resistive or the dynamic flow resistive component of the airway pressure is, plus the static or elastic component, and then plus or minus PEEP. There is an inertance component, but it's insignificant, so it's not usually included in this equation. This equation, I think for engineers particularly, if people can understand this, it will make mechanical ventilation and modes of ventilation and all of those supposedly complex issues much clearer.
Tom, 2 minutes left, please.
Okay. So again, we could just go over negative pressure ventilation, spontaneous breathing, what's involved in that, inspiration and expiration, and then the main goals of ventilation. So oxygen in, carbon dioxide out, and in achieving that, we need to minimize risk of ventilator-induced lung injury, reduce the patient's work of breathing, optimize patient comfort, and then we see the sort of the characteristics or the tools we have to influence minute ventilation, tidal volume and rate, and to influence oxygenation, PEEP and FiO2. Have a quick look at the sort of common modes now that are used for COVID-19 patients: volume control, pressure support. A look at the graphics that we see on the ventilators, the settings, the measurements, and the three main scalars that we use, pressure, volume, and flow over time to interpret what's going on with the patient. Talk a little bit about the settings, common settings, some of the more important ones. And then this is just a summary slide, which kind of shows everything working together. Now, there's many more slides in the full presentation, but this is just representing the ventilator, the breathing system, the various filters we may use, and again, just inspiration, gas delivery, and so on. So that's a kind of a quick flavor, I suppose, of the full presentation. It normally takes about 45 minutes because there's a lot of animations and questions come in during the presentation. So that's it for me.
Thank you, Tom, for the wonderful presentation. And there is a lot of information in the presentation for all participants to read through. And without further ado, I would like to introduce our next speakers. We have two speakers from Rwanda, Pauline and Kostika, and they will share with us some interesting and great achievements that they have done in their country, and they have developed an interesting machine, and I don't want to spoil the surprise. Over to you, Pauline.
And Tom, you need to release the screen, Tom Larkin.
Yeah, please share your screen as we agreed.
Good Good morning, good afternoon, or good evening. My name is Pauline Bangotti. I'm a teacher at the University of Rwanda. I work with my colleague, Kostika, who is an engineer. We've met over ventilators, and now we are working together, find a solution for our population. So my presentation, I'll be short because I want to give more time to Kostika as the main engineer on the project to go through. I'll just talk a little bit about is this Rwanda emergency ventilator a sustainable solution for our country, and maybe some of the other low-income countries having such solution. Is it the sustainable global solution for those countries? As the background, you know, most of the time when an epidemic or a pandemic appears, many people remind themselves about ventilators. You can see how poliomyelitis epidemic reminded people about ventilators. In many cases, even in Hong Kong, in China, all the time when there is a H1N1 epidemic, people remember again about ventilators and mechanical ventilation, about respiratory distress, and then it's a good time for people in the field to wake up and come up with solutions. So that's what's happening with COVID. One of the terms which many people learn about was ventilator, ICU, critical care. And so I think it's time to keep that in mind of people and teach and bring to them solution which can be sustainable, so that if the next pandemic or epidemic appear again, people should not be surprised again. So COVID-19 is the pneumonia, and on the middle, last time with Professor Donner, we saw about the hypoxia was in the middle of the problem, and that hypoxia will be the cause of mortality. So need of oxygen supply and ventilator was really at the top, but some low-income countries were suffering from financial capacity and could not afford, and even the global supply market chain was disturbed. So it was difficult for people to meet, to really respond to it. Lucky enough, there was not high demand of vent in low-income countries. So even when you see the ICUs in those countries, ICUs are not really well equipped. Number of ventilators are not, we can't find them, and even the staff are not well trained. So there was a need for an affordable solution which can respond to the level of the country. So that's where that is a friend of my colleague Kostika, sitting in the workshop with this mannequin. So this is the model of the first model of the prototype, the vent, after Kostika came up with the idea. So now it is still in the industry, and we are working on how to make it a little bit smaller to fit in, like in the ambulances. So the principle, I'm sure Kostika will come back to that, is very simple. And as he told me, it was inspired by the MIT event, where they use very simple things we have in our hospital. The BVM is something well known by the resuscitator, and the concentrator of oxygen is well known. So it was just a matter of assembling those pieces and coming up with an automata which could help people to ventilate automatically, so give the appropriate stated mode. So now, what is needed for now? It's a support. So people will come up with many ideas, and but the need is, we need a technical support and financial support, because we know after COVID, there will be a lot of vent in the world, maybe to be distributed, shaped, but that, just like the Japanese proverb says, give me a fish, I will eat today, but teach me how to fish, I will sit on my boat and drink my beer quietly. So people need in Africa now, in low-income countries, they need to be part of the system, to be part of the manufacturing, part of the production, so that the maintenance will be very easy. If you go in many hospitals, you'll find there is a lot of equipment displaced because that people don't know where to touch, even to make it back to into the system. So if we have people in the high-income countries or low-income countries working together in low-income countries to come up with assembling equipment for the need of low-income countries, that will be more sustainable and will help engineers in low-income countries to master and to be on top of what they are driving. So that was the end of my presentation. So Kostika will take the lead now.
And unfortunately, we've got so little time, Kostika, so really just 1 or 2 minutes. Sorry, we've got to get to the second half.
Thanks so much, Tom. So as Dr. Paul said, yes, we have been following the world, how the situation on ventilators. So that's why we came up with this idea to develop low cost. Of course, if I look at the question from colleagues and Adrian, and so, yes, this emergency ventilator may not be used for long term in the ICU, where they have an access to the high-end technology, drug market, and all other brands. But for short terms, for countries like in our setting, we need that type of ventilator. So the other question was that, of course, our machine has a micromotor controlled by software. We also have barrel, as they said. We have microprocessor controlled. The other key element is having a high-end technology, gas flow analyzer, pressure analyzers. So make sure if you want to deliver a certain amount of patient, we have such amounts. So this idea is not high-end, but if we can have at least some countries in Africa developing such few technologies, they will make sure that in case the COVID hit Africa, which may likely to happen, we will not watching people dying without doing anything, because if it happened in Western countries, what if it will happen in Africa? So on WHO side, what we are requesting, and the whole CED and the team, is to mobilize, provide more training. I saw some, materials, but also testing, recommending where to buy good materials and to give a guidance. But we should not say this is the low cost, this is the basic, without supporting this technology. Otherwise, we may have a challenge where we don't have anything to do, just watching people dying. Thank you so much.
Thank you, Kostika. Now we are ready for the long session, question and answers. And we have quite a number of questions. 9 of them already answered. We have a few open. The first question coming from Riyad Farah in Lebanon. And this question is to all panelists. And Riyad is asking about the oxygen plant generation, whether it's needed and necessary if a hospital has its own liquid or oxygen liquid storage and distribution pipelines. So is it necessary to have that plant in the hospital, and where it should be installed?
So this is Elliot. I will quickly comment that we covered oxygen systems in one of the earlier webinars, and there is quite a bit of material that WHO has published on oxygen systems. So I would suggest referring back to that information, and if that is not sufficient, to contact one of us for additional information. Obviously, we need to have oxygen enrichment and sufficient volume. And whether that's liquid or tanks or concentrators depends on the circumstance and location.
Thank you, Elliot. The next question is from Najib. And Najib is asking, what about V and Q mismatch? And I believe he means the cardiopulmonary system, not only the pulmonary system alone. Any answer from the panelists?
Bassett, I was responding to Najib before, so this is like a series of 4 questions that were coming one after the other. And he was asking about the use of the Ambu bag in the ventilators, and then if they can be for long term or not. And then he talked about the pulmonary or just the cardiopulmonary system. So I think in this case, my suggestion, and also the WHO as we have now, is anything that is using the Ambu bag with some kind of a pressure mechanism is not recommended for long stays and for ICU. It is only for emergency use only. And then the other thing that should be very important is any of the ventilators that is approved for emergency use only, it is approved for emergency use only specific in that setting. It could be in a high income setting where the high pressure of oxygen is available, where suctions is available, where there is a nurse-doctor relation per bed, it's high. So I think we should be very careful on any use of the emergency use of ventilators in low income settings. And then, yes, there has been a problem, a cardiopulmonary problem, like a cardiovascular system problem in patients that have COVID. So it is not just only the resistance of the lungs, but also in the circulatory system. So in some cases, they're using anticoagulants and other things. And all this is being researched now. And then there's a new clinical management guidance that will be released by WHO. But I can put the link here of the one that we have now. Over.
Thank you, Adriana. And he also gave a follow-up question regarding using the ventilator with multiple patients. And it's a gray area.
Yeah.
We should not you know, use that as a resort.
I said Tom's got an answer. Tom Larkin.
Yes, please.
Yeah, well, there's a lot of talk about this at the moment, and there's been a lot of recommendations and so on. So I think the SCCM, the AARC, the ACHP, all of these people are not recommending that you use multiple single ventilator in multiple patients. There is some work going on in Galway University in Ireland on a sort of a system that can manage 2 patients at the same time, but some of the characteristics of the patients, like the respiratory mechanics or what PEEP they're on or CPAP they're on or resistance compliance, it's a difficult problem. So the recommendation is, there have been some publications on this over the years, but the recommendation is not to do that unless maybe if you're absolutely back to the wall, you might, it might be better than doing nothing, but certainly it's not recommended.
Thank you, Tom. The next
Elliot and Adriana have their hands up.
Adriana, do you have any further?
Yeah, just to say, so far WHO does not recommend multiple patients for one ventilator, especially in low and middle income countries, because the settings that you have to have and the controls that you have to have are detailed ones. So it is not recommended as of today. And that is, and if the patient has spontaneous breathing and different rates, then maybe you want to go to a non-invasive ventilator first, and then not using one ventilator for 2 patients. Over.
So Kostika had his hand up, and then I'll speak for a moment.
Yes, thank you so much, Kalaf. So my quick question or my quick recommendation is that, of course, we're discussing Ambu vent or low emergency ventilator may not be used, not suitable, but why, if WHO and the team and collaborators, we come up with a basic setting, because we say that it's not allowable, it's not good, but in the end run, they use it. I've seen even FDA giving certifications, other national organizations giving certification because of the need. So why can't we draft something at WHO side, at least to give them guidance that if you want to do vent, you need flow sensor, pressure sensor at this minimum or maximum standard, this type of, even Ambu bag. Some use very low cost Ambu bag in plastic, which has the pollution materials and so on. So can't we come up with some kind of guidance in this situation so that people may know what they're doing exactly?
Elliot, would you like to add
Well, I think
anything
Adriana
here?
has to answer that question on behalf of WHO.
Thank you, Kostika. We have an expert panel, and this expert panel is of therapists. All these problems are brought to this expert panel. We meet every Friday, and then we put all these things into consideration, and then we make WHO makes a recommendation or not. Some high-income countries have approved some emergency use ventilators or the use of the 2 patients with 1 ventilator, but with very specific conditions. They say you need to have all these requirements and so if that is happening in a high-income setting with all the gadgets and resources and pressure gauge and monitors and so, it could be done. So WHO is not opposing to that, but it's not recommending it as a general procedure to be done elsewhere. So those are the kind of things in which we have to distinguish now. And there's so many cases that are coming up in that we cannot keep the pace with all the innovations and solutions. But certainly the most important is to save the patients and do not harm, remember.
So thank you, Adriana. I just want to point out that there are several training programs that are available for free on the proper use of ventilators and ventilation. Some provide free certificates, and these are available globally. They're provided by many different organizations through many different mechanisms. They provide the opportunity to understand which ventilators are appropriate for which situations. They're global, they're not just in the US, and even some of them look at some of these older ventilators that are part of our stockpile of devices and talk about using, for example, bilevel ventilators, bilevel devices, which have been converted for non-invasive or invasive ventilation. The point is that we're learning a lot about ventilators today and oxygen therapy. And throughout the US, one of the current beliefs is, and I can provide articles, that ventilators should be a last resort because the actual survival rate with ventilator care has been very, 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 very low. And that other modes of care are preferred first before going to the ventilator. All of that adds to the complexity of, well, 2 patients on a ventilator. Some have demonstrated 4 patients on a ventilator. These are scientifically and technically complex to manage. But we're not here to talk about clinical decision-making. We're really here to talk about the technologies and the training and the support for the technologies.
Thank you, Elliot. We move to the next question. We have a question about the aerosol and the treatment using the non-invasive ventilation and the high flow nasal cannula. And is there a recommendation to use that procedure to minimize the risk to health workers? We had a webinar on that last week, I believe, but I will give this question to the panelists if they would like to add on that, but I will also recommend Andrew to look at the previous webinar that we had some time ago.
And let me just make a quick comment that it's not only what's going on during the procedure and the use of the ventilator, but decontamination afterwards. So Adriana, I know you might have something. I'm not trying to put you on the spot.
Yeah, we did talk about this in the other seminar, as Bassett says, but it is very important to have a very full protective equipment, everything, and have special care because yes, the aerosolizing gives more risk, higher risk to get contamination for healthcare workers. So it might look as a more economic and easier solution, but on the other hand, we have other challenges and risks to healthcare workers to be infected. So yes, and there is a guidance on this in WHO. We will put everything on the chat for people to read it. Thank you.
Thank you, Adriana. We are running late and we will take a few more questions and then the rest of the questions will be answered in a separate session. The next question, when is volume controlled ventilation and pressure controlled ventilation used? Tom, perhaps you want to answer?
Yeah, so this is the age-old kind of, is this mode of ventilation better than that mode of ventilation versus the other mode of ventilation? And if you look at the literature on mechanical ventilation modes these days, you could be forgiven for assuming that there's about 150 modes of ventilation, but actually there's only about 3 core modes of ventilation. So pressure control versus volume control, they both have their advantages and disadvantages, and it's really about the clinical judgment of the physician in charge or the consultant in charge to decide for that particular patient which mode is more appropriate than another mode. So it's just, you know, you just have to make a decision based on the clinical need of the patient and where you are with that particular patient. Every single patient is different. So you can't, there's no kind of prescribed way of doing things. So be giving another presentation in the next couple of weeks on modes of ventilation and the advantages and disadvantages. So you can't just say volume control is better or pressure control is better. They both have their advantages and disadvantages, but I suspect that pressure controlled ventilation tends to be the more preferred these days because it has value that volume control doesn't have, or it has, you know, functionality that volume control doesn't have. So
yes, Elliot?
And it also, one of the volume control, when you're forcing volume into a patient's lungs, they really can't be conscious. They can't be fighting the ventilator. So there's a decision made about the patient's ability to make breathing efforts and trigger the ventilator, and also the patient to take a reasonably full inspiration. So it becomes a very complicated decision. And in COVID, we know that the actual patient's lungs are remarkably different than most other clinical settings. So it really becomes a clinically complex patient and situation to manage.
Thank you, Elliot.
Yeah. So could I just come back on that? That in any controlled modes of ventilation, patients can't tolerate, you know, being ventilated without being sedated and or paralyzed in an induced coma. So when you're in a control mode, the patient is invariably not interacting with the ventilator. So you're in total sort of sedation, total paralysis, and then, you know, you if you like, ease that off over a period of time and then switch to spontaneous mode. So again, there's a big difference between spontaneous ventilation on a ventilator, non-invasive ventilator, and control modes where the patient is generally completely zonked, as we say.
The other point is that a lot of the really seriously ill patients have other comorbidities and are old, and so their health and vitality is often challenged. So weaning them off a ventilator safely and successfully becomes a whole complex problem for clinicians.
Thank you, Elliot. Unfortunately, we still have a number of questions. We will not be able to answer them, but we will answer them separately and share with all participants. We will move to the last session of today.
Oh, Bassett, just before that, there's a couple that Adriana may be able to answer quickly.
Okay, please, Adriana.
You're on mute, Adriana.
Sorry, I was just answering. There's some concerns about the issue of the Ambu bag. I said, well, you can use them, of course, but it is not like a long-term solution. So just wanted to add that. There is a lot of, there are many questions about the reuse, decontamination. So I want to invite, even if there are some experts here that can help us, because we, as Ale said, we're going to develop training for the use of the ventilators, the decontamination, the reuse, all of these issues, and maybe even have like a procedure for a quick generic maintenance. We're working that with the WHO Academy, so we will be hiring a consultant to help us, but still we would like to have your information, you know, and the idea is that these training courses will be available for all eventually. So this is to the WHO Academy that is doing a lot of apps, and I will send you the link to the apps, because now they have been released just this last week, a lot of apps for COVID patients and how to manage them, and issues about PPE, ventilation, diagnostics, etc. And now that I have the microphone and the floor, I would like to share with you that these past 2 days, including today and yesterday, the World Health Assembly took place. It is the first time ever that this is done virtual. And then if you want to go there, I will put the web in the link, so the link of the website in the chat, so that you can go there and hear what your ministers of health of your countries responded or have said on the importance. Curiously, many are talking about medical equipment. So maybe we can even take those words and paraphrase it, so that then we can get more leverage on all the work that we do. No? So I think I really invite you to go and listen to everything that was said by different healthcare ministers. And the very first part of the assembly was presidents. So there were like maybe 20 presidents talking about COVID and the importance, and somewhere in their sentences you can capture a word on related to our profession and our big goals of having the patient, the importance of the patient, and the importance of having the right technology for the right patient. So I want to take the opportunity to thank you all for your participation, and thank IFMB for helping organize this, and thank Ale that made the presentation today on ventilators, and she and Gabi and others that are working in WHO very with difficult times to really find the best solutions, and also welcome all the innovative solutions to make really good care for patients. Thank you.
Thank you, Adriana. And we're coming to the last 2 minutes of our webinar. I will give a chance to our speakers and panelists if they want to say a few words, the last words before I conclude.
Well, I just make the comment.
Elliot, I would like to tell everybody that we'll be providing information on resources, including testing methodologies that ECRI has provided for ventilators to make it easier for you to do the work that you need to do.
Thank you, Elliot. Tom?
I was just going to say, we're looking for the large issues, the systemic issues, and certainly we've heard training. I mean, Adriana's talked about the WHO Academy, which has the AV capability, if we can add the technical content to that. And so we're going to be following up with her on several things there. We saw through the questions the abuses. We know that ventilators have been sent to countries and they, you know, with not in the right languages and not assured of the quality. And so we want to help try to address that. You've heard Adriana talk about decontamination, trying to bring together information about that. So these are several of the large issues that we want to help respond to. I heard yesterday, Adriana and Ali, about you know, the WHO is preparing a send out at the moment of, you know, equipment to LMIC. I don't know if you have a comment on that.
Thank you, Tom. And
Ale, do you want to talk about how many oxygen concentrators have been purchased or other things like that? Over.
Well, yes, for the time being, we are sending 4,000 oxygen concentrators to different countries, 5 in total, with all the oximetry and oxygen delivery devices. And in general, I just want to thank for following the seminar, for following also the information that has been published, and for sharing your expertise and knowledge. Just a remark that we have different kinds of expertise, and the more we can share, the better we can get in answers and in having like a critical and one perspective that solve all of our doubts. Thank you very much.
Thank you for all our participants today and the speakers, the panelists, for joining us. And I would like to give you two things to take home. The first is be assured that we are there to support and help. And if you feel you need any support, please contact us. You have all the contact information to all speakers, to the WHO, to the IFMBE. And the second thing, as you noticed, medical equipment are seen as a key factor in healthcare delivery. But unfortunately, they're the unsung heroes that still not fully recognized, the clinical engineering and the biomedical engineering professionals. And with that, please remember them. They play a key role in the healthcare delivery system. And with that, this is my last word for today. And thank you again. Be safe and stay safe, and watch for the next coming webinars and information series. Thank you all.
See you at the summary on Friday. Thanks.
Thank you, Tom. Yes, you will get a summary on Friday. Thank you, everybody, and take care. Bye-bye.